Welcome back, scholars, to Mr. Honeycutt's math class. For this video, we're learning about how to determine the extrema graphically, the absolute and the relative maximums and minimums. So first, I want to start with an example where very recently in our lives, people have been talking about maximums and minimums and such. And hey, look, it's the flatten the curve thing. This is the one that's actually for the state of Texas. This is from covidactnow.org if you want to go check it out yourself. And then it shows that if we had done nothing, the hospitals would be overloaded somewhere at the beginning of May. That's for the state of Texas, not the country nationwide. And then ideally with social distancing, we still might have some, but I think that's also why they did the lockdown and the shelter in place. Because even with the social distancing, we were still going to have a maximum that's far above our capacity to do this. So again, this is a very simple example of how maximums and minimums matter in everyday life. So we'll circle back to it in a minute, but the other way, and in fact, this whole max and min is part of a larger piece that we call optimization mathematically. It's one of the most practical things that we do with math in the everyday world. The optimization means find the optimum, find the best. That means you're finding the maximum or finding the minimum. It's like I said, it's probably the most useful skill attached to mathematical modeling. So that a company can use optimization to maximize their profit. They basically can create a mathematical model, an equation about how much materials cost and whatever like this, and how much prices and whatever. What do they set the price at to make the maximum profit? Okay, and public safety officials can use optimization to minimize lives lost. And so how do we design the safest thing given a fixed budget or something like that? That's what we're trying to minimize lives lost. So we're hearing lots, anytime that people are talking about finding max or mins in this sort of way, they're using mathematical modeling. It's a very, very practical, very useful mathematical model. It's funny, it's one of the most practical applications of calculus as well, because there's a calculus version of this. You can do it graphically, but there's a way to do it without graphs at all with calculus. And yet we don't do it so often in calculus classes because the hardest part is actually making the mathematical model. Usually the calculus is so easy, it's almost trivial. So just kind of those weird ironies. But yeah, so what are extrema? Extrema are maximums or minimums. They are the extremes of the graph. Here's one. So that's a max, that's a min. Here's a min, here's a max. Notice, and the reason why I included both these is you can have lines and points. You can have pointy minimums or pointy maximums. They're still maximums. Sometimes kids just think it's just like these. So those are extrema. It's just a fancy way. Instead of saying max or min, we say extrema altogether. A little more on the the vocab as well. Maxima is the plural of maximum. Minima is the plural of minimum. Sometimes you will hear me say maxima and minima. Other times you might hear me say maximums and minimums. That's a Latin thing. And the extrema are extremums, okay? The maximums and minimums. So that's just a little Latin thing with the A ending. Ooh, this graph didn't quite work out so well. Okay, so the extrema, I want to connect this back to this increasing, decreasing. A relative maximum is going to go from increasing to decreasing. That's part of the definition of a maximum. So if it's going from increasing to decreasing, that makes it a relative maximum. Okay? A relative minimum is actually going to go from decreasing to increasing. From decreasing to increasing. I want you to have that in your mind, that connection between maximums, minimums, increasings, and decreasings, because that connection is really, really going to help you in calculus. Mainly, that's how we find maximums, is oftentimes not necessarily finding them directly, but finding that the graph is going from increasing to decreasing. We're able to do that algebraically in calculus. So let's look at this graph real quick. So the graph of f of x, relative extrema. Where does f of x have a relative maximum? F of x has a relative maximum. We can write this a couple of different ways. We could say, hey, x equals -3. I could also say that f at -3 equals 1 is the relative maximum. So that's this guy. Okay, notice that's the relative max. It's gone from increasing to decreasing right there. All right, and the relative min is right here. At what point is that? Well, I could say that that's x equals 1. I could also say that f at 1 is -3. Notice that these mean two different things, okay, even though they look really similar. By the way, it's not always like that with its reversed and stuff. So just be aware of that. This graph just happens to be kind of symmetric like that. So now, we need to talk about absolute or relative extrema. The absolute extrema of a graph is the absolute max or the absolute min. Okay, it's the highest point if it's the max, it's the lowest point if it's the min. So notice that this is a relative max. It's relative to the stuff around it, it's a maximum, but not to everything it is. This is a relative min. Relative to the stuff around it, it's a minimum. However, this one, it is a relative max because relative to the stuff around it, it's a max, but it's also the highest point on the graph, so it's the absolute max as well. Technically, you can have two absolute maximums if they have the exact same height. It's really weird, it's rare, but sometimes they do that. Same thing with the absolute min over here. It's the absolute min, it's the minimum value on the graph. Notice, by the way, that this is an endpoint of the graph, while this one is in the middle. And that's generally kind of a good check thing. You want to check your endpoints for your graph of your domain for absolute or relative max, along with these relative values as well. So and then what the main difference that might matter is the absolute extrema are going to affect the range of the function. Okay, so if a question asked about the range of these, well, you would have to say something like that y is going between f at a and f at d. All right, that would be the range. Okay, but with the relative max and relative mins, that actually doesn't affect the range because they're within the actual range, as in domain and range, of the function. Let's look at some other absolute extrema. So notice again, this would be a relative max. All right, here's another relative max. This little guy is also a relative max. Okay, this is a relative min. Okay, this is actually also a relative min. It's relative to all the stuff around it. All right, this one is an absolute min. Okay, and it's also a relative. Anytime it's an absolute, it's also a relative. All right, right there is also a relative min, a very little one. Okay, and up here, the highest point of the graph would be the absolute max. Okay. So notice, even though there's this weird little jump here between these two, this is still an absolute min. Just wanted to point that out. Another thing that delta math is going to throw out to you are these things called the horizontal tangent lines. I'm not going to introduce this concept right now. I just want you to know that when they're saying horizontal tangent lines, what they mean is this, 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 and this. It goes right there. So notice that these are happening at a maximum, a relative max, a relative max, a relative max, relative max, relative max, relative max. Hey, there's a connection between what these horizontal tangent lines and relative max. For right now, all that really matters for the delta math is when they say the words horizontal tangent line, they're just it's another way of asking about the relative maxes or the relative mins. All right, other than that, don't worry about it. All right, so back to our COVID-19 example. So notice this is a relative max, and this is another relative max. And these are the relative maxes that we're trying to avoid. So we're trying to optimize, trying to like figure out, and then they're building these mathematical models to try to figure out what are the things that we can do to prevent all sorts of death. So we are living through a real world optimization problem right now. So after this, you've got to finish the problems on Go Formative, and then you'll have lots of questions on Delta Math to practice these. Thank you for your time. I hope you learned something. And can we fix everything? No, but we can fix something today. There's a lot going on in the world. There's not much we can fix, but we can do little things. We can fix little parts of our lives. Keep fixing things. Keep solving problems by problem solvers.